Hi friends, welcome to GMK tutorials. In this video, we are going to start our discussion on unit number 3, most important questions for GATE point of view as well as end semester exam point of view also, or maybe if you go for any competitive exam point of view. Okay, so ఈ వీడియోలో మనం ఏం చేస్తున్నాం, most of the guys are requested please తెలుగులో చెప్పండి అని అడుగున్నారు. So I will use both English and Telugu, okay, for our convenience and better understanding point of view. సో ఈ వీడియోలో మనం యూనిట్ నెంబర్ 3 లో ఇంపార్టెంట్ క్వశ్చన్స్ ఏమున్నాయి అంటే ఒక్కొక్క కాన్సెప్ట్ ఒక్కొక్క క్వశ్చన్ కవర్ చేసే పాయింట్ ఆఫ్ లో కొన్ని ర్యాండమ్ గా కొన్ని 10 క్వశ్చన్స్ కలెక్ట్ చేసాం. ఈ 10 క్వశ్చన్స్ అనేవి మేబీ యూస్ఫుల్ అవ్వచ్చు ఇన్ టర్మ్స్ ఆఫ్ థియరీ పాయింట్ ఆఫ్ లో కానీ ఇన్ టర్మ్స్ ఆఫ్ ఆబ్జెక్టివ్ పాయింట్ ఆఫ్ లో కానీ. ఓకేనా? సో ఐ హోప్ దిస్ వీడియో హెల్ప్స్ ఎ లాట్ ఫర్ ది బిగినర్స్ ఆల్సో. ఇప్పటివరకు ఎవరైనా వీడియో కవర్ అంటే ఫస్ట్ ప్రిపరేషన్ స్టార్ట్ చేయకపోయినా ఈ వీడియో చూస్తే దెన్ యూ విల్ గెట్ సమ్ బేసిక్ నాలెడ్జ్. ఓకే, సో ఎలా ప్రాబ్లమ్ సాల్వ్ చేయాలి. ఓకే, సో డోంట్ వేస్ట్ అవర్ టైమ్, జస్ట్ లెట్స్ స్టార్ట్ అవర్ వీడియో. Let's go on to the topic. So the first question in unit number 3, first question is nothing but, so it is also one of the most important topic. So a closed loop system is shown in figure, okay, figure where k is greater than 0, at the same time alpha is also greater than 0. So the steady state error due to the ramp input is given by, so whatever system closed system ఇచ్చేస్తున్నారు closed loop system. సో ఇన్పుట్ అనేది ఆర్ఆర్ఎస్ అనేది ర్యాంప్ ఇన్పుట్ అయితే వాట్ ఈస్ ద స్టడీ స్టేట్ ఎర్రర్ అంటున్నాడు. ఓకే, సో స్టడీ స్టేట్ ఎర్రర్ ఫైండ్ అవుట్ చేయండి అంటున్నాడు. సో ఫర్ దట్ పర్పస్, సో బేసికలీ దిస్ ఇస్ ద కంట్రోల్ సిస్టమ్, రైట్? సో ఎవ్రీ సిస్టమ్ is also having input, gain, feedback path. Okay, so this is the output section. So error is nothing but the difference between input and feedback is generally called as error. Okay, so steady state error calculate change. So for that purpose we will go through the basics. I don't want to touch all the basics here, it is not possible to cover all the topics also. So just I will use the formula based point of view. So మీరు ఇక్కడ C of S అంటే మీకు G of S into E of S వస్తుంది. So from this also you can calculate the values also. Okay, so that is also like you will get a R of S by, like R of S by 1 plus G of S into H of S, E of S value. So దీనికి ఫైనల్ వాల్యూ థీరం అప్లై చేస్తారంటే you will get the solution. So this is also general model for this case. Okay, so this is just a model for this one. Just based on this analysis you can find out the steady state value. So for this case what ఏమంటున్నా అంటే స్టడీ స్టేట్ ఎర్రర్ వాల్యూ ఫైండ్ అవుట్ చేయండి అంటున్నాడు. సో ఫస్ట్ ఆఫ్ ఆల్ ఇట్ ఇస్ ర్యాంప్ ఇన్పుట్ అంటే మనకు ఒక బేసిక్ ఐడియా ఉండాలి. ఓకేనా? సో ఆబ్వియస్లీ బేసిక్ ఐడియా ఉంది అంటే యూ కెన్ డైరెక్ట్లీ, సో మనకి ర్యాంప్ ఇన్పుట్ క్యాల్కులేట్ చేసేటప్పుడు వీ కెన్ యూస్ డైరెక్ట్లీ స్టడీ స్టేట్ ఎర్రర్ ఈస్ నథింగ్ బట్ కేవీ అని చెప్పాం. అంటే కేవీ ఇస్ ద, సో కేవీ ఈజ్ ఈక్వల్ టు, దిస్ ఇస్ ద ఫార్ములా. సో బేస్డ్ ఆన్ దిస్ యూ కెన్ ఈఎస్ఎస్ వాల్యూ ఈజ్ ఈక్వల్ టు ఏ బై కేవీ. దిస్ ఇస్ జనరలైజ్డ్ ఫార్ములా. సో ఈ ఫార్ములా యూజ్ చేసుకుని కేవీకి ఫైండ్ అవుట్ చేస్తాం, దెన్ సబ్స్టిట్యూట్ చేస్తాం, యూ కెన్ ఫైండ్ అవుట్ ది ESS. This is a generalized pattern for any case. It may be ramp input or maybe step input or maybe unit, whatever it may be. So this is a based on, okay. So from this basic you can find out the solution for this case, right? So in this point of view, from the given information, what is the useful thing here? That is nothing but, so R of S is equal, they mentioned that R of S is equal alpha by S square. So already question load mentioned చేసేసారు. At the same time ది ఓపెన్ లూప్, సో మనం ఈ స్టడీ స్టేట్ ఎర్రర్లో మోస్ట్లీ మనం ఓపెన్ లూప్ ట్రాన్స్ఫర్ ఫంక్షన్ యూజ్ చేసుకొని మనం ఈ కోఎఫిషియెంట్స్ వాల్యూ ఫైండ్ అవుట్ చేస్తాం. ఓకే, సో ఫర్ దట్ పర్పస్ G of S into H of S, they mention that, okay, so the feedback path is the gain of 1, therefore it is a unity feedback, therefore G of S into H of S, G of S is nothing but this one, therefore the product of these two gives the K divided by S into S plus 2 gives the open loop transfer function. So for this case, if you want to find out the KV, the formula, so this is the ESS formula. So ఈ కేసులో ఆల్ఫా ఉంది, మేబీ జనరల్ కేసెస్ దే మే బి కన్సిడర్ ఏ ఆల్సో ఆర్ మేబీ 1 ఆల్సో. సో డోంట్ రెస్ట్రిక్టెడ్ టు 1 value. Okay, so this is generalized way. As per the given data we can write the formula ESS is equal to the amplitude divided by KV. So for this case, for unit step case, you will get a 1 by KV also. Okay, so therefore KV formula is equal, from the final value theorem, KV is equal to limit S tends to 0, S into G of S into H of S. This is nothing but open loop transfer function. So g of s into h of s is equal, substitute this one, then s get cancelled, therefore you will get k divided by 0 plus 2. So by applying the limit s tends to 0 value to this one, then you will get a k by 2. This is a value, right? Now we need to find, this is a kV, that is nothing but velocity constant here, right? Positional error constant, velocity constant. Okay, so in this case ESS is equal to 1 by kV, right? Therefore alpha divided by k by 2. So that is the answer for ESS. So option number alpha by k. So 2 alpha by k is the answer, right answer for this question. Okay, I hope it is clear, guys. In case, whatever the case, in case if you want to find out the formula, kp is equal, same formula. Okay, kp is equal to, for kp case we are not getting s value, right? Therefore g of s into h of s only. Okay, now g of, for k case you will get s square into g of s into h. So this is very important. If you know these basics, you can find out the steady state errors and the steady state error coefficients also. Okay. The second question in this part is nothing but, let y of s be the unit step response. Y of t and y of s అనేది unit step యొక్క response అంటున్నారు. At the same time, it is a causal system. And a causal system means that the output depends only on present and past values. So they mentioned that g of s ఇచ్చేసారు, ఓకేనా, and so having a causal system, having a transfer function. So sorry, they mentioned that transfer function also. That is y of s is equal, mention that g of having a transfer function g of s is equal to, that is y of s is equal to g of s. Sorry, they mentioned that g of s, at the same time transfer function is equal to y of s. So they mentioned that transfer function y of s is equal to the forced response, the transfer function in this case, wait a minute, output by system having a transfer function. Okay, so they mentioned that no need to think about the transfer function point, just we need a basic data is enough. Y of s is equal to, so g of s by into es. So they mentioned that unit step is nothing but 1 by s, right? So y of s is equal to r of s, that is nothing but transfer function. So this is a general relation, right? Output is equal to transfer function into input. So from this criteria, r of s is equal 1 by s, because of it is a unit step function. They mentioned that information also. Now you need to find out the y of t, force response. Response is nothing but obviously time domain. Okay, therefore you need to find out the time domain value of the corresponding output function. So for that purpose, let us see here. G of s is a given data, right? Y of s is equal also given data. So from that, y of s is equal, substitute g of s values in this equation, you will get like this. So by using a, you need to find out the, you need to use the partial fractions for this case. So let us assume there is some constant k1, k2. Therefore k1 by s and k1 by s plus 1, s plus. By using any method, whatever you learned in your previous classes, you will go through the any method, by your residue method or maybe LCM method. So find out the k1 and k2 and k3 values, you will get the solution. So in this case, if you want to find out the, just I will mention k1 value find out just the general the corresponding pole value mention cheyali, overall transfer function and unit step. Suppose k1 is equal to, k1 find out chesinappudu, k1 is equal to the pole, yes, complete transfer function, that y of s value, y of s, right, s is equal to pole value 0 దగ్గర ఇలా find out చేయాలి, So by substituting SS cancellation ఏమంటే చెక్ చేస్తాం, substitute చేయండి s value, you will get the value. So ఈ cases లో SS cancellation అవుతుంది, then you will get only s is equal to 0, 3 divided by 3, then you will get the value of 1. That is a simple method, way of calculating the constant values. Okay, I think you have some basic idea, no need to worry about it. So at the same time, by substituting all the, by calculating all k1, k2, k3, you will substitute in the first equation. Let it be considered. If it is if you are taking a equation number 1, substitute all the k1 values in this equation. You will try to represent it like this. Now it is a y of s format, so I don't require only time domain response. So for that purpose, you need to apply the inverse Laplace transform. 1 by s is equal to u of t. So here also e power minus t format. So e power minus ct. So that is obviously e power minus at is equal to Laplace transform 1 by s plus a. The inverse is nothing but similar. So if you are comparing with 1, e power minus t. If you are it is a 2, e power minus 2t. So based on that one, you can take the values of that one. So this is a forced response. This is nothing but a transient response. Transient means that obviously it takes a certain time to reach the final value. So this period of time is generally called the transient time T. This is nothing but a steady state time Ts. So that is the answer for this one. Okay. So u of t is equal to, they mentioned that u of t minus 2 into, I think the option, which one is correct? U of t minus 2 into u of t plus, I think option A is the right answer. We don't have any quotient values. One quotient value is also important. Then the questions, I think, so we don't have any quotient. Therefore, option u of t minus e power minus 2t into u of t. Sorry, just a minute. 1 minus, so quotient 1 minus 2. 1 minus 2. So option A is the right answer. Answer is the option A. Okay. So question number 3, they mentioned that in the question number 3, they mentioned in the question, the output of the standard second order system for a unit step input is given. Okay, na? Second order system ka standard equation mention chesaru. From that unit, maybe it is a square root of 3, I think. Okay, square root of 3 into t, not a square root of 3, it's just only square root of 3 only. Square root is only for 3 only, okay, not for 3. So this is a generalized information. From that they mention that y of t is also there. Then the transfer function of the system. So some information ఇచ్చేసి ఇక్కడ నుంచి ట్రాన్స్ఫర్ ఫంక్షన్ ఫైండ్ అవుట్ చేయండి అన్నారు. మరి ట్రాన్స్ఫర్ ఫంక్షన్ ఫైండ్ అవుట్ చేయాలి అంటే మనకి సెకండ్ ఆర్డర్ సిస్టమ్ కి లెట్ us use పవర్ పాయింట్ ఫర్ అనాలిసిస్ పాయింట్ ఆఫ్ వ్యూ. So generally the second order system transfer function, okay, transfer function for second order system. Second order system transfer function is basically that is nothing but omega n square by s square plus 2 zeta omega n s plus omega n square. This is a standard function, right? Suppose if you want to define this transfer function, you need a zeta value, omega value. If you know these two values, you can definitely find out the values. So from the given information, this is a given information. From there, this is a standard. If you are comparing this with the standard equation, you will get some data. So this part is equal to square root of 2 by root 3 is equal to multiplication factor of 1 by square root. So the 1 by square root of 1 minus zeta square 2 by 3. From that, if you are squaring on both sides, you will get a value of zeta is equal to 1 by 2. Right? You get a value of zeta is equal to 1 by 2. Now, if you know the zeta value, obviously, if you are comparing with the standard equation, or maybe if you are taking with a omega d point of view, so omega d value is equal to root 3. So therefore, omega d is equal to omega n into square root of 1 minus zeta square. Therefore, omega d is equal to root 3 omega n into square root of 1 minus zeta square. Zeta value is equal to 1 by 2. Therefore, substitute this value, you will get omega n is equal to omega n is equal to root 3 get cancelled from this. Then you will get only omega n is equal to. If you know the omega n value and the zeta value, you can definitely write down the CSS, second order equation. Therefore, CSS is equal to omega n square by s square plus 2 zeta omega ns plus omega. Obviously, it is very easy, guys. If you know the basics, everything will be easy. Okay. So this is a underdamped case. Therefore, so that is a very important. Okay. So from there, omega n square by, so omega n is equal to 2, therefore 4 divided by s square 2 zeta omega ns plus omega. So 4 value. So zeta value is equal to 1 by 2, omega n is equal to 2. So those two get cancelled. Therefore, you will get C of s is equal to 4 by s square plus 2s plus 4. This is the second order equation. Though right answer is nothing but option 4 is the right answer. The fourth question is nothing but they mentioned that the natural frequency of a underdamped system of order omega is nothing but undamped second order system is for natural frequency. Natural frequency is nothing but omega n, that is nothing but 40 radians. They mentioned that 40 radians per second. At the same time, if the system is damped with a damping ratio, they mentioned that zeta value is also equal to 0.3. Okay. Then damped natural frequency and is what is the omega d value calculation? Omega d is equal to what is the value? So omega d is equal to general for omega n into square root of 1 minus zeta square, right? If you know these two values, substitute those two values, you will get a 38.15 is the answer for this question. If you know the basics, damped frequency, damped natural frequency, that is in omega d. Okay. So that is the answer for this also. That is a NAT type. So next one is nothing but, so I will cover all the models. I think you will get some glance about up to now, right? A unity feedback system, unity negative feedback system has an open loop transfer function is G of S. So that means obviously G of S into H of S value is equal to that value, right? G of S into H of S, because of it is a unity feedback divided by K divided by S into S plus 10. Okay, fine. From that, what they are expecting is the gain K for a system to have a damping ratio is equal to 0. And the zeta value is equal to 0.25 రావాలి అంటే what is the value of K అంటున్నాడు. A యొక్క K value కి you will get zeta is equal to 0.25 వస్తుంది అంటున్నాడు. So for that purpose, let us solve the basics from one. So this is a given information, K value తెలియదు, zeta is equal to 0.25, you can represent 1 by 4 also. Suppose if you want to find out the damping ratio and all those things, obviously you need to take the transfer function equation. From the transfer function equation, you have to choose the characteristic equation. Therefore, CH equation of the is equal to, for this system, second order system, open loop transfer function point out. From that, 1 plus G of S into H of S is the characteristic equation formula. From that, take the G of S value in this equation, you will get a S square plus 10S plus K is equal to 0. Suppose if you are comparing with the standard equation of the second order system, this is a value. So now we don't have a value of K value తెలియదు, right? So from this K value తెలియదు. At the same time, suppose if you are comparing with the standard equation for this one, 2 zeta omega n is equal to 10, right? It is clear. At the same time, zeta is equal to 1 by 4. Therefore, zeta is equal to 1 by 4, omega n is equal to 10. After that, 2 5s, right? Therefore, from this you will get omega n is equal to 5 into 4, that is equal to 20. Therefore, from this omega n is equal to 20, right? If you know the omega n value, obviously you can find out the K value, because if you are comparing this equation, the K value is nothing but omega n square, right? So K is equal to omega n square. Therefore, K is equal to 20 whole square is equal, that gives rise to 400. So K value is equal to 400. Therefore, the right answer for this question is nothing but option D is the right answer. So the right answer is option D. So question number 6. The open loop transfer function with a unity feedback, they mention this one, for the peak system, for the peak overshoot of the closed loop system to a unit input is, so peak overshoot control, maybe we can call it the MP, maximum peak overshoot. So peak overshoot, maximum peak value. Okay, so maximum peak overshoot is nothing but we can in terms of MP values, right? So for that purpose, they mention that in terms of percentage, what is the value of K antunnadu. So for that purpose, it is a very important model, guys. Okay, be patient here. It is a very important model. So there is some tricky questions in this case. Suppose if you want to find out all these values, obviously you need to take the second order characteristic equation, no doubt at all. Suppose if you want to find out any value in the third unit, compulsory you need to take the second order equation. So So by taking the second order equation, but comparing all these values, this is our actual, this is the standard CH equation, right? So from this given data, what are the values you are getting here? That is nothing but omega n square. What is the value of omega n square? Omega n square is equal to here, omega n square is equal to k, because of if you are comparing those two. At the same time, 2 zeta omega n value is equal to 2. At the same time, omega is equal to. So omega value, we don't have any value. So for that purpose, we need to calculate omega n is equal to square root of k from this. And substitute that value, you will get the value of zeta is equal to 1 by root k. Okay, up to now it's very clear. Okay, therefore zeta square is equal 1 by k square. From that k is equal 1 by zeta square. Okay, fine. Up to now it is also okay, fine. Now we need to find out the k value. So k value find out here, and they mentioned that some more information. That is nothing but MP value is equal to 10%. Therefore MP is equal to nothing but maximum peak rate, then 10%, that can be represented as a 0.1. Therefore substituting in that mention that formula, e power minus zeta pi by square root of 1 minus zeta square equals 0.1. Now in this equation, what are the information you have? So if you are taking the natural logarithm, then you will get ln of 0.5 some value ln, and at the same time left side zeta pi by square root of 1 minus zeta square. You know that obviously from the given information you that zeta is equal to square root of 1 by k. Okay, by calculating all those values, you will get the value of zeta is equal to 0. So from this also you can find out the zeta value, right? E power zeta pi by square root of 1 minus zeta square, ln value you will get some value. Obviously from this zeta value you will get 0.599. If you know the zeta value, obviously k is nothing but 1 by zeta square, right? Therefore, by substituting zeta is equal to 0.5, in this case, you will get a k value is equal to 2.8. Okay, 2.86. So the right answer is nothing but option C. So this is some more related role. In case they mention that any value, it may be rise time, whatever it may be. If they mention that certain case rise time, you can find out the zeta value on it. So whatever the case. So that is the case also. At the same time, suppose if you go for the seventh question, they mention that from the seventh question they mention that the system with a open loop transfer function ichesadu and type of the system and the order. Obviously we know that, right? Type of the system is nothing but the number of poles located at origin దగ్గర ఉండేదాన్ని మనం type అని చెప్తాం. పవర్ ఆఫ్ s వచ్చేసి ఆర్డర్ అని చెప్తాం. హియర్ s స్క్వేర్ అవుతుంది కదా, ఆర్డర్ 2 అవుతుంది. ఓకే, ఆర్డర్ ఆఫ్ ది సిస్టమ్ ఇస్ ఏ, సో టైప్ ఆఫ్ ది సిస్టమ్ వచ్చేసి 1 అవుతుంది. ఓకే, సో ది పోల్ లొకేషన్స్ s is equal 0 దగ్గర ఉన్న, s is equal -2 దగ్గర. సో therefore the right answer is type 1 system order 2. So the right answer is the option D is the right answer. The same time for 8th question, for a unity feedback control system, unity feedback control system, they mention that g of s value that is equal to this one, and the given information is nothing but some system may be mentioned here also. So what is a steady state error due to the unit step input ki steady state error enti antunnadu. So obviously first of all, if you want to find out this kind of the problem, first of all you have to check the type of the system. So based on that one you can directly, or else you will go for the generalized method also. If you don't have any idea about the steady state error for the unit step ante you will calculate the kp value is equal to limit s tends to 0 g of s into h of s. This is the formula. So g of s into h of s is nothing but 2 divided by s into s plus 1, right? Therefore if you are substituting that value, limit s tends to 0 2 by s into s plus 1. By substituting s is equal to 0, you will get kp value is equal to 1 by 0, that is equal to infinity. So ess is equal to 1 by kp, right, per unit. So here amplitude is equal 1 only, right? Therefore 1 by kp, that is equal 0. That is the ess case. Suppose they mention that in case any value, follow the table like this. So in case maybe unit step, this is the formula, unit velocity and parabolic. Okay, so these are the different questions for, there may be chances for ESS point of view, steady state positional error constant, okay, velocity coefficient and acceleration coefficient, or maybe parabolic point of view. So these are the three cases, okay. So for KV point of view, the formula is existing, only difference S into G of S into H of S. For Ka point of view, that is nothing but S square into G of S into H of S. So here G of S into H of S is nothing but open loop transfer function. That is the most important thing in this kind of the ESS point of view. Okay, steady state point of view. Okay, so we will move on to the ninth question. That is nothing but the ninth question states that the input to the controller is a input to the controller is a error signal, right? So why? Because the controller is essentially the controller is essentially a comparator which compares the given input with the reference input and generates the error signal. The reference input is the actual signal input of the control system. Error signal is the input to the controller and it causes the output to the desired output. Okay, now. So those are some of the related points to this one. So next one is nothing but what is the correct statement in this case? Obviously, correct statement mentioned. The proportional controller stabilizes the gain but produces the steady state error. Okay, correct. At the same time, the integral controller reduces or eliminates the steady state error. Right answer. The derivative controller reduces the rate of change of error. So these three statements are valid statements. Therefore, option C is the correct answer. Apart from this, okay, apart from these questions, I will give some more important formulas and important conclusions for help for the objective or maybe any questions. So here the one of the most important points, some of the points. So that is nothing but first note, the Kp and K values are describe the ability of the system to reduce the steady state error. That is the one point. At the same time, second one is nothing but the higher the type of the system. Suppose if the type of the system if the type of the system is increases, the steady state error is also eliminated. But if you go for the higher order system, there is a two drawbacks, two limitations. Is there? One is nothing but if the order of the system is increases, difficult to stabilize. So stability అనేది కష్టం అవుతుంది. At the same time, the dynamic errors for such a kind of a higher order system is completely different from the normal values for type 0, type 1 and type 2 cases. So that is some more problems. At the same time, for ESS point of view also, suppose if you go for the steady state error constant, there is a two limitations or maybe two disadvantages. One is nothing but the error constants. Disadvantage is that they do not give information steady state error when inputs other than step ramp input. The steady state error coefficients cannot give the information in case if the input is other than that of the step, ramp and parabolic. That is the one drawback. At the same time, the error constant cannot fail to describe the error changes with the time. Maybe how the exact manner in which error is changed with the time. Time to ఎలా చేంజ్ అవుతుంది ఎర్రర్ అనే ఇన్ఫర్మేషన్ మనకి ఎక్కడ ఈ స్టడీ స్టేట్ ఎర్రర్ కోఎఫిషియెంట్స్ అనేవి ఇన్ఫర్మేషన్ ప్రొవైడ్ చేయవు. These are the limitations, right? Coming to the some important points of view, the effect of adding a zero to the system. Suppose if you are adding a zero to the system, it is also one of the important zero to the system. At that time, the early peak is existing. Suppose if you are taking a peak case like, so is the one case. But if you are adding a zero, the peak value is existing before only. That is nothing but addition of zero. Suppose if the zero is away from the origin, the effect of zero on the system is also very less. If the zero is near to the pole, near to the origin, at that time the peak is existing very early compared to the previous case. So this is a generalized formula for this one. Cz of t, that is nothing but response of zero added to the system. Cz of t is equal to actual system, that is nothing but C of t plus 1 by z into d by dt of C of t. That is a formula for this case. At the same time, some more formulas for our analysis point of view, that is nothing but rise time TR is equal to pi minus pi by omega t. It is nothing but under damped case. Suppose for critically damped case, that is different. Rise time TR is equal to the amount of time taken by the system to rise from 10% to 90%. So that is nothing but rise time. 10% means 90%. That means rise time అని చెప్తాం. At the same time, delay time is equal to, it reaches 0 to 50% for general point of view. That is nothing but delay time. Therefore, TD is equal to 1 plus 0.7 zeta by omega. Maybe it may be also called as 62.7% of its final value. That is also one more definition. So 0 to general point of view, it is a 0 to 50% for critically damped cases also. Okay. So where TP is nothing but peak time, that is equal to pi by omega d. Where omega d is nothing but damped frequency, that is nothing but omega n into square root of 1 minus zeta square. MP is nothing but maximum peak overshoot also. Okay. Therefore, e power pi zeta by square root of 1 minus zeta. These are the formulas. For settling time, TS is equal to 4 by zeta omega n. Settling time is nothing the time taken by the system to rise from 0 to 98% of its final value. So that is the consideration, right? 98 and 90% of its final value. Based on that one, settling time TS is equal to 4 by zeta omega and 3 by 0. So this is a 2% older, it is a 5%. There is a one more settling time format. TS is equal to 6 by zeta omega. It is only for critically damped case. Okay, that is also very important. At the same time, the rise time TR is equal to 2.2 time constant for over damped case. In case if they mention that specially over damped case, what is the rise time? At that time we will take 2.2 time constant, 2.2 into 2. So the same time constant for our system, that is a different criteria. Therefore, at the same time, the second order system C of t, that is nothing but step response of the second order system for under damped case. C of t is equal to 1 minus e power zeta omega n by square root of 1 minus zeta square into sine of omega dd plus pi, or maybe theta also, maybe theta also pi. So at the same time, cos pi is equal to theta, or cos theta is equal to 0. So from that we can find out the theta is equal to cos inverse of zeta. At the same time, you know the right angle triangle for this one also. Okay, zeta into square root of 1 minus zeta square. Okay, zeta. So from that also you will get the information. So these are all about the some of the related information for unit number 3. I think I hope this video is very helps a lot. Okay, as per my convention, but I don't know exactly as per your point of view. I will try to cover all the points. So some more definitions is also there. Suppose if you want to find out the rise time and peak time, some more definitions is also there. Please go through that derivations. You will get the rise time TR by taking the second order system. C of t is equal by taking the second order system at t is equal to TR value. Okay, na? That t is equal to TR, rise time is equal to, it maybe reaches 95% or maybe. So these are the different cases. For critically damped case, it may be over damped case 10% to 90%. Critically damped for 5% to 95%. Okay. So for under damped case, it is a 0 to 100%. So critically damped for under damped case. Suppose if you go for under damped case, at that time the value is equal to. Therefore, the C of t value is equal to 1 at t is equal to TR case. So that is a procedure. Substitute that value, C of TR is equal to 1 consider handy. Okay. Then equate to that one, then you will find out the TR value. Obviously, that is a derivation pattern. Okay. Na? So see at t is equal to TR case, for under damped case, the C of t value is equal to 1. Therefore, substitute C of t is equal to 1, you will get the rise time. That is the one pattern. At the same time, for maximum peak overshoot is also same thing. For maximum peak overshoot also, the pattern should be same. Therefore, C of infinity is equal to 1. That is nothing but final value consider చేస్తామంటే 1 అవుతుంది. Therefore, take this 1 as a analysis point of view, then you will take the process also. Okay. So that is I don't want to go for the derivation point of view because of the time constraint. So I hope this video is up to now it is very clear. Okay.